Talking about 6.2, which is the unit circle. Before 6.1, we actually talked about the introduction where you see that these angles in degrees go up to 360, which is also considered 2 pi. And you have it in radians. Your biggest denominator is when it's the smallest angle. And the 6 and the 5 pi over 6 are both 30 degrees apart from the x-axis. So that's why we would say the reference angle equal 30 degrees on both of them. The reference angle is always considered from the x-axis, not the y-axis. So it's not 60, the reference would be 30. And like you saw on the quiz, if you have a square root of 3 over 2 here, then you would straight down also. Straight down, square root of 3 over 2. This is a positive half, this is a negative. And straight across, negative square root of 3 over 2 with a positive a half. And then straight down, negative square root of 3 over 2 with negative a half. And then it comes over. So if you want to do a box like that visually for the 60s, I mean, you can do whatever you want, it's your paper. And then your pi over 3 goes to the 5 pi over 3, and to the 2 pi over 3, and to the 4 pi over 3. So think 1 pi over 3, 2 pi over 3, 3 pi over 3 would be pi, 4 pi over 3, 5 pi over 3, 6 pi over 3 would be there. And then let's count by sixes, or like the 6 denominator. 1 pi over 6, 2 pi over 6 is pi thirds, 3 pi over 6 is pi halves, 4 pi over 6 is 2 pi thirds, 5 pi over 6, 6 pi over 6. So if we stop right there, think if this is pi, then 5/6 is a little bit smaller. And then 4/6 is even smaller, which changes to 2/3. And then it just continues from here. 7 pi over 6, 8 pi over 6, which is 4 pi thirds, 9 pi over 6, which is really 3 pi halves, 10 pi over 6, which is really 5 pi thirds, 11 pi over 6, which is close to 12 pi over 6, which is 2 pi. Also notice that all of the square root of 3's over 2's go together. Yes, they have different signs, but they all go together. You never have both of them square root of 3 over 2. You never have both of them a half. The only one that's a duplicate is at the pi fourths. This is both square root of 2 over 2 for both of these. And on this one, it's the same thing except for one of them's negative, the other's positive. Here, both are negative. And here, one is positive, one is negative. So hope that helps as far as the unit circle again. Now there's a whole paragraph, or actually a couple of pages about it. I might just let you read through this because we've talked through some of it already. We're talking about a radius of 1, and so it's 2 pi. Remember the circumference is 2 pi r? Well, if r is 1, then that's 2 pi units. That's why that would make sense. So the point of the unit circle is to make other parts of math easier and neater. You can even now understand how the unit circle can be useful. For example, y is sine, cosine is x. So remember x, y for each of these. Now also, what I saw could be helpful is if you like write quadrant 1 is plus plus, Quadrant 2 is minus plus. Quadrant 3 is minus minus. And quadrant 4 is plus minus. So notice that's true for all of these. Okay. And see, there are times when in the Math Excel it wants an exact answer, and that's when it's going to relate to either 0, 30, 45, 60, or a multiple. So other things, like part of this we already talked about on the very first video about graphing the trig functions, and your domain for sine and cosine is all reals, and the range is -1 to 1. The reason is because you think you're 1 and -1 here. Sine goes through the origin, and so it looks like that. So that's sine. Cosine starts a little bit to the right and then goes. I don't think I showed that combination before on the calculator, but that's true. So make sure you're graphing in degree mode, in radian mode. So I click radian, and then sine x. So that's the wavy one. By the way, if I did degree mode, it'd be a flat line, and that's wrong. So again, you got to be smart, and it doesn't look right, but it doesn't give you an error message. So you kind of got to know what to look for. You want it to be wavy. And then if you go to cosine of x, that's going to be just a little bit to the left or right, depending on your perspective. I think you do minus pi halves to make a match. Yeah. See how it turned purple? And then if you go to your table, this 0.84 in the sine column matches this 0.84 in the cosine column. But just to go over again, in your table, these numbers are not going to help unless you change your settings. So go to your table, Control T, menu, table, settings. You're really going to want to step by pi force or something like that. This one shows 0, 1. I'm skipping 1 because that's the square root of 2 over 2. And then another one, and then now if you see something like this with an e to the negative number, think of that as 0. So it went 0, skip 1, 0, skip, -1, skip, 0, and so forth. So it's oscillating between -1 and 1. Okay, so a lot of that we've talked about some up to some point. Here I say draw. Some of these things we've talked about. Sine is y, cosine is x, tangent is y over x, cosecant is 1 over sine, secant is 1 over cosine, cotangent is x over y, or you could think 1 over tan. And then here I say draw it. Sine is positive in quadrants 1 and 2. So the reason is because all this is where sine is positive. For cosine, it starts at 0, 1 and then comes on down. And so cosine is positive on this end, where x is positive. This other one with sine plus is y positive. Then tangent looks like that. And so in this quadrant, and then your inverse of sine would be cosecant, so that would also be positive right there. Your inverse of cosine would be secant, so that would also, and tangent is positive there, so cotan would also be positive there in 1 and 3. One and 4 for cosine. Okay. I guess here I give you a table similar to what was on your other thing that you did by hand for those. I give you some common decimals because sometimes if you're using your calculator you could recognize a decimal, but they're asking about an exact answer. So that's why this could be useful a little bit. Yeah. Okay, so now let's get into it. Now our first couple are actually from 6-1, like really close to the end. So the thing about linear speed is, first, linear speed could be thought of as miles per hour, like miles over hours, or meters per second. You have this formula, just double check real quick. I think it's with V and with W. Okay, so that was right. Your linear speed formula, I'm going to write over here. Your linear speed is V equal S over T, and your angular speed would be W equal theta over T. So the angular speed would be things like degrees per second, radians per second or minute or whatever. It's not how fast you get angry. So in this problem, we have V equal S over T, and our T is 20 seconds. So we have V equal S, which was a distance, so we use S equal R theta. So for this particular problem, not only do you use this formula, you use this one. So the S equal R theta was one we used in the last lesson, and that's your radius, which is 9, times your theta, which is 1/4. So that's 9/4. So our V would be 9/4 over your time, which is 20. So when we do 9/4 divide by 20, whoops, I did 0.2. That gives you 9/80ths. So whenever you're doing these problems, there's 2 steps. Now for your W equal theta over T, W equal theta over T, and our theta is 1/4, and your T is 20. You're doing 1/4 divided by 20. And that's 1/80th. And then the other thing was your units. If it's linear speed, it's going to be the one without a power of 2. And like in this example, it's inches per second. And on this one, it's radians per second. So that's how you do the first one. Then on this one, you have some scientific notation because it's saying the mean or average distance of a moon from a planet is this particular distance with a lot of zeros. So it's a big number. Assuming the orbit of the moon around the planet is 1 revolution circular, taking 22.7 days, not 365. And 1 day on this planet is 22 hours, not 24. Find the linear speed. So you're going to have to do some calculations without using your 24 hours a day and 365 days in a year. So here are the formulas you need for this problem. The first one is there's a formula relating linear speed and angular speed. It's V equal R theta. I mean, really, I just said it. V equal RW. V equal RW. So before we can actually do our W, we have to do this step, which uses your theta over T. Since it is a complete circle, we're saying 2 pi, and it takes 22 hours, not 24, and we can simplify that to pi over 11. Then for your V equal RW, we just plug in our radius, which is your 2.11 times 10 to the 5th, and multiply it by pi over 11. It wants you to round to the nearest integer, so let's do that. 2.11 times 10 up arrow 5 times pi over 11. Control enter. So what I just noticed is I used the 22 hours, but I didn't use the 22.7 days. So our formula was right, but we have one extra step. We have 2 pi in 22.7 days and 1 day in 22 hours for your days to cancel. So then it's going to be pi over 22.7 times 11. 22.7 times 11 is 249.7. And then we got to plug that in to right there. V equal 2.11 times 10 to the 5th times pi over 249.7. And that gives you 2654.68. Well, we want to the whole number, And so based on the 6, we have to round up. 2655. 2655 is right there. Okay, so that's how you do problem 2. Okay, on problem 3, it says at the museum you can see the 4 cable lines that are used to pull cable cars up and down a hill. Each cable travels at a speed of 7.45 miles per hour, caused by a rotating wheel whose diameter is 5.5 feet. So the radius would be 5.5 divided by 2, which is 2.75 feet. And it wants to know how fast the wheel is rotating. Express it in revolutions per minute. So what we do on this one is we use V equal RW, and we want to solve for W, and so we have V over R. We know our V is 7.45 because that's your velocity. Velocity and speed in this case are the same. Velocity technically has a direction, whereas speed is a scalar. But for our purposes, they're the same. 7.45 miles per hour. And your diameter tells you, or your diameter is given, make sure you divide by 2 to get your 2.75. Now the problem is, when you have something like this, look at your units. This one's in miles, and this one's in feet. And this is in hours, but our answer should be in minutes. And so we've got some extra conversions. So before we can actually do our work, I'm going to just make a little chart. 1 mile has 5,280 feet. So now we're in feet. And this was miles per hour. And we need to go to minutes. So 1 hour has 60 minutes. So now I'm in feet per minute. So whenever you see something like this, there's several ways you could think about it. You could either multiply your numerators and divide by multiplying your denominators, or you could say 7.45 over 1 times this over 1 times 1/60th. There are a couple of different ways to group it together. What I do is I usually just type it like this: 7.45 times 5,280 divide by 60. So what we do with that is get our answer 655.6 feet per minute. But that was just our little conversion part. We didn't do anything with the 2.75 yet. So again, this has multiple parts. That becomes your numerator, and then we divide by 2.75. In that case, we would just be in like per minute, basically. And you also have your 1 revolution in 2 pi. So I would type that like this: 655.6 divided by 2.75 times 2 pi. Notice my entire denominator has a parentheses, and that's what I want. And then I get 37.942, and based on the 2 we round down, so 37.94, which is your answer. Okay, those are probably the hardest ones. Not actually surprised because these problems were pretty close to problem 100 in the other section, but it was about linear speed, angular speed, and things we needed to cover. So now the rest of this is basically looking at your unit circle and figuring it out. So first off, we have a negative square root of 3 over 2, comma, a half. What you can do is look at that, and that's 5 pi over 6. Now, for your sine, it's the y answer. For your cosine, it's the x answer. So you basically just say the y part goes here, the x part goes there. Now for your tangent, it's y over x. And so you're going to have 1/2 divided by negative square root of 3 over 2. Or if you want to write it this other way, 1/2 divided by negative square root of 3 over 2. Like a fraction over a fraction, you can. And recognize that your 2's cancel, and so you get negative 1 over square root of 3. That's my preferable way. And then you do times square root is 3 over square root of 3, which gives you negative square root of 3 over 3. That's my preferable method. Some people may want to have it horizontal division, and so you change your division to multiplication and flip it. This works pretty nicely also, where you see your 2's cancel and you get negative 1 over square root of 3. And then you have to rationalize it like we did here and turn it into this. Now for your cosecant, the easiest way to remember that is it's 1 over sine, which is basically 1 over y. Originally we had 1/2, now it's 2. And now on secant, it's 1 over cosine, which is 1 over x. So this is basically flipping negative square root of 3 over 2. So it's 1 over negative square root of 3 over 2, which when you flip it, it becomes negative 2 over square root of 3. And then you got to rationalize it. So you get negative 2 square root of 3 over 3. That's how you get that. And then on this one, you take your negative 1 over square root of 3 and flip it. And so that gives you negative square root of 3. Because this is 1 over tan, or you could think x over y. Now, this particular question says it's a random ordered pair, which doesn't show up anywhere on here, but guess what? It does say it's a point on the unit circle. So if it does say it's on the unit circle, then this is your x, this is your y, this is your cosine, this is your sine. So you have your y answer for sine, your x answer for cosine. Now, by the way, be careful because sometimes they change the order of these. I can't remember what year it was, but you had sine, cosine, tangent, cosecant fourth one time, and another time they put cotangent fourth. So don't just memorize that. This one had cosecant fourth. So does this. So just be careful. Cosecant is 1 over sine. You could think these go together. And so you flip negative 1/7. This one you want to do 1 over cosine. And so you flip 4 square root of 3 over 7. So when you do that, you get 7 over 4 square root of 3. And then you want to multiply by square root of 3 over square root of 3 to get your square root out of the denominator. So then that gives you 7 square root of 3 over 4 times 3, which is 7 square root of 3 over 12. Okay. And then on this one, it's 1 over tangent. And so our tangent answer was that. So flip negative square root of 3 over 12. And so then you get negative 12 over square root of 3. Now, the shortcut for this division is just to say 12 divided by 3 is 4, so it's negative 4 square root of 3. If you're not into shortcuts, that's fine. You could say negative 12 over square root of 3 times square root of 3 over square root of 3, which gives you negative 12 square root of 3 over 3, and then see how it turns into that. But sometimes, like, I break the square root just to divide it, and then I know I have to have a square root of 3. So that's how the math works for it to work out. Be really careful on shortcuts. This one, we want the secant of 4 pi. So first, let's think 0. If we loop around once, we get 2 pi. If we loop around again, we get 4 pi. Now your original ordered pair was 1, 0, and cosine was 1. And if you flip 1, you get 1. So that's your answer. Now, they don't want you to use a calculator, so that's how I showed it that way. But if you were in radian mode and you did secant 4 pi, it would show you it's 1. Okay, that's probably good for that part of the video. On this one, you're getting to the sum of trig functions, and I'll do that in a separate video.